Hello students, welcome back to Future Foundation. Students, in this video, I am going to discuss question from JEE Main held on 29th Jan Shift 2. And the question I am taking from limits. So let's start. Question says, if limit of integral 3x plus 5 whole to the power t dx within the limit 0 to 1 whole power 1 by t as t tends to 0 is equal to alpha upon 5e times 8 upon 5 whole to the power 2 by 3, then alpha is equal to. Students, question is integer based, means its value will be integer. So what we need to do, we need to solve this in limit and nothing. Okay, so let's do accordingly. What we do in questions of limit, first of all we check the form, right? How we can check the form? By putting the limit. If I put t is equal to 0 in place of t in the argument in LHS, see what form will it be formed? So integral 0 to 1 3x plus 5 whole to the power 0 dx within the limit 1 by 0, right? So 3x plus 5 whole to the power 0 is 1. So integral 0 to 1 dx whole to the power infinity, or integral of dx is x within the limit 0 to 1 means it is 1 to the power infinity. So form is 1 to the power infinity, right students? Form is 1 to the power infinity. So in this form, what we generally do, we write this as e to the power limit fx minus 1 into gx. Fx is argument inside the bracket. So inside the bracket is this. This is fx. Fx minus 1 into gx, and this whole is gx, right? So fx minus 1 into gx. Gx is this. Now we have to find integral. Okay, so this is nothing but px plus q whole to the power n type. So it is limit t tends to 0, 3x plus 5 whole to the power t plus 1 upon t plus 1 into 1 by 3, because we divide coefficient of x, right? Minus 1 into 1 by t, right? This is e to the power limit t tends to 0 by taking LCM. This will be okay, and within the limit this is 0 to 1. Okay, so after putting the limits in integral, what will it become? E to the power t plus 1 minus 5 to the power t plus 1 upon 3 into t plus 1 minus 1 into 1 by t, right? So e to the power limit t tends to 0. After taking LCM, it will become 8 to the power t plus 1 minus 5 to the power t plus 1 minus 3t minus 3 on 3t into t plus 1, right? Now if I see the form is 0 by 0. Okay, so if form is 0 by 0, I can use LH rule, using L'Hopital's rule. It says you can differentiate numerator and denominator separately. So this will become 8 to the power t plus 1 into ln 8 minus 5 to the power t plus 1 into ln 5 minus 3 upon 3 times 2t plus 1, right? Now Again, if I put limit, then form is not indeterminate. It is now determinate form. Okay. So e to the power 8 ln 8 minus 5 ln 5 minus 3 upon 3, right? Or it can be written as ln e to the power 8 minus ln 5 to the power 5 minus 3 upon 3. Okay. Or this can be written as e to the power ln 8 to the power 8 upon 5 to the power 5 into 1 by 3 minus 1. Or this can be written as e to the power ln 8 to the power 8 upon 5 to the power 5 whole power 1 by 3 by using property of log minus 1 or e into e to the power minus 1. Now this can be written as e to the power 8 upon 5 to the power 5 whole power 1 by 3 into 1 by a. Okay. Now this thing I can compare according to the question which is given in the question. Question says this limit is equal to alpha upon 5e 8 upon 5 whole power 2 by 3. If I make LHS according to RHS, then I can take 5 from 5 to the power 5. So outside I can write 1 by 5e, right? But this 5 to the power 5 is actually having whole power 1 by 3. So if I write outside 5, then inside it will be 1 upon 5 to the power 2 by 3, because 5 to the power 2 by 3 into 5 to the power 1 is 5 to the power 5 by 3, right? Okay. Also, if I write inside bracket 8 to the power 2 by 3, so outside, if I write inside 8 to the power 2 by 3, so outside I have to write 8 to the power 2, 8 to the power 2, because 8 to the power 2 into 8 to the power 2 by 3 is 8 to the power 8 by 3. Okay. And is equal to alpha upon 5e 8 upon 5 whole power 2 by 3. And this in LHS I can write 8 by 5 whole power 2 by 3. So now if I compare both sides, then alpha is nothing but 8 square. So alpha is 64 and 64 is the required answer. Okay, 64 is the required answer. So students, let's meet in next video. Till then, bye bye and take care.